So, get this. By 2050, projections show the UK could have, well, something like 30 million electric vehicles on the roads.
30 million. Wow.
Yeah, it's a huge jump. I mean, think about it. Back in 2020, we were looking at under a million.
That kind of shift, it really does raise a big question, doesn't it? What about all the cars we already have?
Yeah.
The petrol ones, the diesels.
Exactly. What happens to them? And that's precisely what we're diving into today. This idea of converting existing cars, the internal combustion engine, and what ICE cars, into EVs. It's often called retrofitting.
Mm-hmm.
Could this actually be a smart way forward? Avoid scrapping millions of vehicles, maybe help cut pollution.
It's definitely a timely question, especially with the UK's ban on selling new petrol and diesel cars coming up in 2030.
Right. And then that even stricter target for 2035, all new cars and vans, zero emissions.
Exactly. So retrofitting, it isn't just some, interesting side project. For a lot of people, it might actually be a faster, maybe even more affordable way to get into a zero-emission vehicle than buying brand new.
That's a good point. The cost of new EVs is still a barrier for many.
And think about the running costs, too. Lower fuel cost with electricity, potentially lower maintenance, plus avoiding those low emission zone charges. That could really add up.
For sure. Okay, so to really unpack this, we've got some solid material we're looking at today.
Yeah, there's a pretty comprehensive study on easy components and where the tech is heading.
And alongside that, some specific UK research looking into, well, the potential need for proper regulations and maybe some kind of quality mark for these EV retrofits.
Right, an accreditation scheme.
So our mission really is to pull out the key stuff from these sources, understand the tech involved, the practicalities, and what it could all mean.
And if we zoom out for a second, the why behind looking at retrofitting becomes really clear, environmentally speaking.
You mean the emissions?
Definitely. Road transport is a huge chunk of the UK's greenhouse gas emissions, passenger cars especially. Back in 2019, transport overall was about 27% of total UK emissions.
27%, wow.
And of that transport slice, road transport cars, vans, lorries, was responsible for a massive 91%. That's about 110.7 million tons of CO2 equivalent.
Gosh.
And here's the kicker. Passenger cars alone accounted for 68% of all those road transport emissions.
Okay, those numbers really paint a picture. It shows just how big an impact switching cars could have.
It really does. And it ties directly into that legally binding target the UK has, doesn't it? Net zero greenhouse gas emissions by 2050.
Right. It's not just a nice to have, it's a legal requirement.
Exactly.
Yeah.
And there's another interesting angle here. The life cycle impact.
You mean from making the car to scrapping it?
Precisely. Some studies suggest that a retrofitted electric car actually has a lower overall environmental footprint than building a brand new electric car from scratch.
Really? Lower than a new EV?
Yeah, and significantly lower than keeping an old petrol or diesel car running, obviously. One source puts the impact level for a converted EV at around 72 grams, compared to about 97 grams for a new one.
So you're saving on the manufacturing impact, essentially, using what's already there.
Exactly. Fewer raw materials, less energy used in production compared to tuning out a completely new vehicle. It adds up over the car's remaining life.
Okay, so the environmental case, the net zero targets, it all points towards needing solutions like this. But let's get down to the nuts and bolts. What does retrofitting actually involve?
Well, it's a pretty major operation, as you can imagine. You're essentially taking out the heart of the old car.
The engine, the petrol tank?
Right, the engine, fuel tank, the exhaust system, even the radiator, all that comes out. And in its place, you're installing an electric motor and a battery powertrain.
Battery powertrain. So that's the battery pack itself and all the bits that get the power to the motor.
Exactly. The batteries store the energy, and the system manages delivering it to drive the wheels. It's a complete power source swap.
And I guess you get all the usual EV benefits then. Cleaner air, potentially cheaper running.
Absolutely. Our sources mention those, plus things like a smoother, quieter drive, less vibration, simpler mechanics.
Which might mean less driver fatigue, maybe, especially in city traffic.
That's the idea. And financially, yeah, the evidence points to lower running cost electricity versus petrol or diesel, plus usually less maintenance needed on electric motors compared to combustion engines.
Have people looked at converting specific car models? Does it work for most things?
Well, the research has definitely explored it. There's mention of studies looking into converting, for example, a Mercedes-Benz class A190.
Yeah.
It suggests that, yeah, a pretty wide range of vehicles can be adapted. It's feasible.
That's good to know. It's not just, kit cars or something. So what are the key bits you need for the conversion? Motors, batteries. What types are typically used?
For motors, the sources often talk about BLDC motors, brushless DC, which are known for being efficient,
Yeah, okay.
and also induction motors, which are quite robust and pretty common in EVs generally.
And the batteries, I guess that's the crucial part for range.
Absolutely. Lithium-based batteries are generally the go-to choice for conversions now. Things like lithium-ion, they pack a good amount of energy for their size and weight.
Right, energy density. And just like buying a new EV, the bigger the battery capacity, the further you can go.
Pretty much, yeah. The range of a retrofitted EV is directly linked to how much energy its battery can store.
What sort of ranges are we talking?
Well, the study mentions typical ranges might be somewhere between, say, 100 and 250 kilometers. That's roughly 60 to 150 miles. Some top-end conversions might push towards 500 kilometers, but that would need a big battery pack.
Okay, so enough for commuting or local trips for many people.
For sure. But it's important to remember, just like any EV, the actual range you get depends on lots of things: how you drive, the hills, even if the heater's on full blast.
Fair enough. And the charging time is still a factor compared to just filling up with petrol, right?
Oh, absolutely. That's still one of the trade-offs with EVs, converted or not. Charging takes longer than a 5-minute fuel stop. That hasn't changed.
Okay, so we're basically putting a modern high-voltage electrical system into a car body that wasn't originally designed for it. That sounds like it brings some serious safety things to think about.
That is a really, really vital point. Safety is paramount. You're dealing with high-voltage batteries and cables.
Much higher voltage than a normal car battery.
Oh, significantly higher.
Mm.
And the big risk is the amount of energy they store. If there's a fault, like a short circuit, they can discharge that energy incredibly quickly.
Which could mean electric shock or fire.
Exactly. Serious risk of shock and potential for fires. And another thing is, even when the car's switched off, the high-voltage system can remain live. So it's a constant potential hazard that needs careful design, insulation, and protection.
Right. Are there other hazards besides the purely electrical ones?
Yes, definitely. The batteries themselves, lithium-ion ones, contain chemicals. If the battery casing gets damaged, say in a crash, or if they're mishandled, they can release harmful substances.
Okay.
And then there's the fire risk again, particularly thermal runaway, if a battery is severely damaged in a collision. These fires can be notoriously difficult to put out.
And what about the car itself? Adding a heavy battery pack must change things.
Absolutely. Weight distribution is a huge factor. These old chassis weren't designed to carry potentially hundreds of kilos of battery, often in a different place than the old engine and fuel tank.
So that affects handling, braking?
Potentially, yes. It needs very careful engineering assessment. How does it affect the suspension? The braking system? Is the chassis strong enough? And crucially, the battery needs to be mounted incredibly securely so it doesn't break loose in an accident.
Makes sense. And there's another thing. EVs are quiet, right? Especially at low speeds. Is that a safety issue in itself?
That's an excellent point, and yes, it is. Pedestrians, cyclists, visually impaired people often rely on hearing traffic. A nearly silent vehicle approaching can be dangerous, particularly in towns and cities.
I hadn't really thought of that in the retrofit context.
Studies have shown there's an increased risk. That's why new EVs have those acoustic vehicle alerting systems, AVAS.
Artificial noisemakers.
Exactly. They generate a sound, usually when the vehicle is traveling below about 20 miles per hour, just to let people know it's there. There's actually a UN regulation for it, number 138, for new, quiet vehicles.
Okay, so a whole raft of safety challenges to get right. Which brings us to the rules. What's the situation in the UK right now if someone does convert their car? How's it regulated?
Well, this is where it gets interesting. Currently, if you convert a car or a van and want to change the fuel type on the registration, document the V5C with the DVLA to electricity.
Yeah, what do you need to do?
It seems, based on the sources, the main requirement is just providing evidence of the change, like a receipt or maybe a letter from the garage that did the work.
Wait, that's it. No specific safety inspection for the high voltage stuff or checking the handling changes.
For cars and vans, it appears not as a mandatory specific part of that fuel type change process. It seems surprisingly administrative.
That does sound a bit, well, minimal given the scale of the changes we just discussed. Is it different for bigger vehicles?
Yes, it is. For buses, for instance, if they get converted, the process is much more rigorous. They need detailed test reports submitted, and there's the potential for an inspection by the authorities at a proper test facility.
Okay, so there's a clear difference there. But for cars, once it's registered as electric, what happens with things like congestion charges?
That's another interesting point. Once it's officially registered as electric, a retrofitted car or van can usually become exempt from charges like the London congestion charge or clean air zone fees elsewhere.
Even if the CO2 emissions on the paperwork might still say not available or even list the old petrol engine's value.
Apparently so. Based on the current situation described in our sources, it's treated as electric for those charging purposes.
So you could have a situation where the conversion maybe wasn't done to the highest standard, but still gets the financial benefits.
That's the potential risk, with the lack of standardized regulations and mandatory inspections, specifically for light vehicle retrofits. It could lead to, well, variable quality. People might use secondhand parts, maybe even damaged ones, without proper checks.
So are there any standards people can look to?
Well, the safety guidelines developed for new electric vehicles offer a good starting point. Things like the visual checks used in the IVA, Individual Vehicle Approval Test, for new low-volume cars, checking high-voltage cable connections, making sure HV cables are orange, checking the earth paths.
Right.
Those principles are obviously very relevant even if they aren't legally mandated in the same way for a retrofit changing fuel type. And there's Regulation 100 UNES R100, which is all about electrical safety for EVs. It's a detailed technical guide.
It really sounds like there's a bit of a gap then between the potential safety issues and the current rules for cars and vans.
That seems to be the assessment, yes, which leads to thinking about the future.
Like maybe a more formal system.
Exactly. The idea of an accreditation scheme specifically for EV retrofits in the UK is definitely being discussed.
What would that involve?
The goal would be to set clear, consistent standards for safety and quality. Businesses doing conversions would need to meet these standards to get accredited. It's about building trust and ensuring things are done properly.
It feels like that would be necessary, right? Moving beyond just ticking a box on a form.
Absolutely. There's a growing feeling that a more robust process is needed for cars and vans, something closer perhaps to what's done for buses, but tailored.
Because it seems some companies are already doing good work, but it's maybe not universal.
That's what the research suggests. Some established retrofitters are already doing detailed engineering work, CAD modeling, battery testing, considering various safety regulations like the UN rules for braking, R13, steering, R79, even rollover structure for some vehicles, R107, and functional safety standards like ISO 26262.
So the expertise is out there.
It is. But the level of rigor can vary a lot. Having clear regulations and a recognized accreditation scheme could really help standardize things, boost confidence in the whole retrofit market, and make it a much more viable option for more people.
Okay, so wrapping this up then. It feels like retrofitting older cars to electric. It has real potential, doesn't it? Both for the environment and maybe as another route for people to get into EV ownership.
Definitely potential, but, and it's a big but, the safety aspects are critical and can't be overlooked.
And the current rules in the UK, especially for cars and vans, seem like they might need an update to really make sure those conversions are safe and reliable.
That seems to be the consensus, yes. An accreditation scheme could be a really important step forward.
So it leaves us with a really interesting thought, doesn't it? As battery tech keeps getting better and, the pressure to cut carbon emissions keeps growing, could a properly regulated, maybe even thriving retrofit industry become a really significant part of the shift to EVs?
It's a fascinating question. Could it change how we think about the cars we already own? Maybe extend their useful life in a cleaner way, even globally.
And what about the skills needed? Garages, technicians? Would we need a whole new set of skills, maybe new industries popping up to support it all?
Yeah, what does that mean for jobs, for training, for the whole circular economy idea in the car world? Lots to think about.
Definitely food for thought. If this deep dive has got you thinking about EV retrofits, maybe have a look online, see what companies or initiatives are out there. It's a really interesting mix of old tech meeting new, all driven by sustainability.
It certainly is.
Thanks for joining us for this deep dive.